Hi, welcome to a Curve tutorial video. My name is Natan Cohen. I'm the head of customer success here at Curve. And in this video, we're going to be covering some more features and capabilities of record level security. Things like passing multiple values, handling numeric and date ranges, how to handle multiple security groups within the same data set, or even multiple data sets referenced in the same dashboard. And we'll also touch on some more advanced features like wildcards and boolean nested logic. Now, if you're not familiar with record level security, we do have a tutorial on the basic end-to-end process for setting it up. I'd encourage you to watch that first. And with that, let's get into it. So let's start by heading over to the partner portal. I've loaded the record level security documentation, and I've gone down to the attribute definition section here. It's under the permission schema for RLS. And I'm going to point your attention to the different validation types. It's not just equal, which is good for passing a single value or multiple values, but there are different types of validations. Some are only valid for numeric data, some are valid for string data, and some can work with dates and others not. And then there are some special value declarations that you should use if you want to define numerical ranges. So let's get into our first example here, passing more than one value to the equal validation type. So moving over here to Visual Studio Code, I'm going to pass multiple values here in the RLS block that I already set up, and this is in a backend REST API that was built in Node. So if you want to follow along, you should make these changes in a backend process to ensure that all RLS permission declarations and configurations are securely encrypted before they are sent back to the client. And you can watch a tutorial video to set up a Node.js backend, and you can watch the basic RLS tutorial to get an idea of how this permission block was added. So for starters, I'm going to just define and pass some additional product IDs that I know exist in my data set. I have a record level security group defined on a column called product ID. It's in a specific data set. So notice that the values property was an array to begin with. It's an array of primitives, in this case strings, so I can simply pass that. And I can use equal or not equal. In this case, it would behave more like an in list or not in list. So now I'm going to save this, restart the Node server, and give it a test. So here I am back in the browser. I'm going to reload my front end. All right, and to verify that it worked, I'm going to add a filter on product ID. All right, and as expected, we have the 3 that were passed, and those are the only 3 that I can access, so it appears that it worked. Now we're going to go back to Visual Studio Code and do an example of a numerical range. So back in Visual Studio Code, if we're going to pass a range of product IDs, first we have to change the validation type to range. And then instead of listing all possible values in a comma delimited list, we're going to use a greater than or equal to or less than or equal to syntax. And the syntax we need to use actually makes the value property become an object. So we're going to transform it into an object. We're going to define a property called GTE, greater than or equal to. And we're going to specify 300 as our starting range, and then less than or equal to 399. And with that, I'm going to save it, restart my Node service, and test. So back in the browser here, I'm just going to do a quick refresh. I see that I have some data, but to verify that my range worked, I'm going to do a filter on product ID, and I'm going to verify that I only see product IDs in the 300 range, and they stop at 399, so it looks like that worked. Now let's go back and try a date range, but in order to do that, we need to configure a column in the data set, which is a date for record level security. So to test a date range, I'm going to pop into my data set where I've defined an RLS security group on product ID. And I'm going to go ahead and define one on the modified date for the product inventory. So we'll call this RLS underscore mod date prod INV. All right, apply the changes. And then we'll pop over to Visual Studio Code and set the date range. All right, so now let's add our date range values. And now I have two security group columns in the same data set. So I'm going to take this object, I'm going to copy it, I'm going to add a comma here, and I'm going to paste it. Okay. And now we have two security group fields, and I'm going to rename this one RLS underscore mod date underscore prod INV. And for this, we're going to leave it as equals because we're not really defining a range. What I want to do is limit the dates to only those dates that fall in a specific year. So to do that, I'm going to leave validation type to equal, but I'm going to add a new property called group underscore value, which only works with date time data. And I'm going to set it to year. Now you can set this to quarter, week, day, all the way down to hour, minute, and second if you have that level of granularity. And I'm going to add an extra comma, and then the value is going to be 2025. So now I should be limited to all products, but only those that fall in 2025. So let's pop over to the browser and give it a test. So I'm going to refresh my browser. And a good indication that this worked is that the indicator chart no longer displays a data comparison for 2024. A better way to confirm that my date range filter worked is to go into the specific field that I applied the security group filter to and take a look at my possible individual date selections, noting that now I can only select dates that are in 2025. So that's an example of using a date range filter on numeric values as well as dates. Let's take a look at how we support multiple data sets referenced in a single dashboard where you have multiple charts that are built off of multiple data sets. So I've gone in here to my dashboard that we've been embedding and testing with RLS, and I went ahead and added a new chart that's sourced from a completely different data set. So now what I'm going to do is go back to my list of data sets, go to the new data set with that chart I just added, and I'm going to set a new RLS field on the country region code. I'll call this RLS underscore country code. Apply changes. And now we're going to flip over to Visual Studio Code and we're going to set the security value. And now that I'm back here in Visual Studio Code, we're going to define a completely new permission block for a brand new data set. I'm going to add a comma here. I'm going to paste this. And I'm going to remove one of these security groups. All right, and I'm going to replace it with RLS underscore country code. And I'm going to set it equal to the US. And I'm going to go grab my dataset ID the exact same way that I did the last time. Now I'm ready to give it a test. Before I do, one thing I will mention is that if you have multiple reference data sets in a single dashboard, it's not necessary to copy and paste this block over and over again if, and only if, the security groups for each data set match, which is often the case, especially when you use RLS on the same column to filter out tenant security values. Then what you need to do is simply comma delimit the data sets that have commonality, right? So you could do something like this. And if you're pretty sure that all the data sets referenced have the exact same security group columns defined, then what you can do is effectively replace the whole dataset ID reference with star, but only if every dataset has the exact same number and type of record level security group definitions. So let's go give this a test. So here we are back in the browser, and I'm going to refresh, and we're going to go down and see if it worked. And it looks like it did. It's now restricted to US. All right, let's go back to Visual Studio Code and let's see one final example using nested Boolean logic with ands and ors. So we have two security groups here defined on this data set, and the Boolean logic as to how it applies these values is a bit unclear, but the default is and, which is the safest default when it comes to security. So the product ID in this case is allowed to be anything, but the modified date on product inventory must be constrained to 2025. So the default is and. You can change that behavior by adding the operator property right here after the dataset ID. Remember, the default is and you could set it to or, and now there would be or logic applied between these two security groups for this data set. Now we also support nested hierarchical Boolean logic, and I'm going to show you an example of how to do that. I'm going to switch this back to the default and what I'm going to do is copy the record permissions property here in its entirety, and the way you do this is by creating another object in the top level record permissions block and pasting a new record permissions block within it. So now we have a hierarchical object array. So I'm going to be right back, clean up the indentation here so that it's more legible. All right. So here we are with all the indentation properly set. So basically you can see that I have a top level record permissions property, and I defined a new object in that array, and then basically copied and pasted the entire record permissions block here. So now I have some hierarchical logic, but I need to also add an operator at this level and instruct it how to treat the following security groups. So I'm going to make that an or. I'm also going to clean up this little entry here at the bottom. Okay, so now we have a valid JSON hierarchy. So to make this example work, what I'm going to do is just change the operators at the top level to an or, this one to an and. I'm going to use some real product IDs that I know exist instead of star. So here's how to read this logic. What we're saying is that the product ID must be equal to 764, or the product ID must be equal to 325, and the modification date for product inventory must be in the year 2025. So with that, I'm going to save it, restart my service, and test it. Here we are in the browser. I'm just going to give this a quick refresh. And it seems like we have some data. Let's verify that the filter logic worked. So first of all, I should only see product IDs 325 and 764. But if I see 325, I should also make sure that my possible dates are in 2025. Now, I also see 2022 because product ID 764 had an entry in that year. So that's an example of hierarchical nested Boolean logic. Before we wrap up, let's go back to Visual Studio Code for one last point. One last point to mention, you might be wondering, how large can this widget configuration object get? Each security group that you define effectively becomes a term in a where clause. And depending on the data set that you're using, if it's a managed data set, you would be going against Elasticsearch. If it's a Live Connect, it would be whatever the Live Connect source is. So there are limits on how many nested hierarchical terms you can include in a where clause, but they also they number in the tens of thousands. So you just want to check that if you really think you're brushing up against those limits. In this video, we covered some more advanced capabilities and features for record level security, and you saw examples of numerical ranges, nested hierarchical Boolean logic, how to handle multiple reference data sets in a dashboard, as well as multiple security groups. So thanks very much for watching.